I just wanted to say a few words. So my name is Henrik Leopold. I'm a professor for data science and business intelligence here at KLU. And I wanted to just say 2 words about Stefanie Rinderle-Ma, who's a professor for information systems and business process management at the TUM, how we would say in German, at TU Munich. I just want to set a little bit of context why I'm really excited that Stefanie agreed to be here, because today we will talk about logistics and the future of logistics. And when we think about the future of logistics, now we think of garbage trucks, but we also think about AI. Most of us think about AI and how to use AI. And I think it's important to realize that when we, as organizations think about the use of AI, that we can be excited about AI because it's exciting, it's interesting, right? So if you look out there, what's possible. But as organizations, we ask ourselves, how can we create value using AI or technology in general? And if we actually want to realize how we can create value for our organization or for our customers, then we need to go a step back, right? So we need to understand our processes first. And this is why I'm really excited that Stefanie is here. Stefanie is an expert in business process management, also in process technology, and she also has a lot of experience how to use process technology to actually create value, and that is the connection, and I hope you are excited as well. So now I would like to introduce Professor Stefanie Rinderle-Ma to the stage.
Yeah, welcome also from my side, and thank you very much for the very kind introduction. So I'm really excited to be here, and I was particularly excited when I read the theme of the day, bringing together exciting areas. So we have transformation, digital transformation, we have AI, and we have logistics, and in the next, let's say about half an hour, 45 minutes, I want to convey some ideas and thoughts and work that we have done and can we possibly bring together these topics. And my talk is about conversational process modeling, and I will try to make a connection to logistics here. And at some certain point in time, it was, I think, announced as controversial process modeling, what I also love, because I hope that we can also have controversial discussions about this, because particularly the use of AI can be also seen as a controversial part. So, very nice, and let me start with a motivation. So, as Henrik said in the beginning, processes are a key for digital transformation. And I can only agree on this. So my team and I, we have experience, particularly in manufacturing, but also the related logistics aspects for more than 20 years. I can also not believe it, but it's true. And we have seen that companies, particularly SMEs, but also bigger companies, can really benefit if they introduce a process-oriented thinking. Because the processes are the central piece that brings together all aspects that are relevant in a company. And in addition to that, I mean, maybe you have also kind of seen all these trends going on, particularly process mining and process automation have become really hot topics nowadays. So I was at the conference of the biggest process mining vendor software company last year, and they rented the whole hangar at the Munich airport, and there were 3,000 enthusiastic people from industry, all believing in process mining, and that process mining can really bring value to their businesses. And I have to admit, I was really impressed. So there's a lot of going on, and I think there's really, and I also would agree that it's definitely true, a big hope that process mining will also really bring digital transformation further. And what is exciting, but at the same time sometimes hard to understand, processes are everywhere. So we can find processes in any application domain. And as I said before, we have mainly been looking into manufacturing and logistics and also healthcare. And I'm very excited about these domains because for me they're more exciting than these classical office automation things like loan application or something like this. Here the processes are so exciting because they bring together systems, humans, and also the physical world. Yeah, you have sensors, for example. Yeah, I talked to Henrik before, and for example, container transportation, I think in container you have plenty of sensors measuring all different kinds of things. Same holds for manufacturing. Yeah, we have seen processes producing a small valve. A valve is a part of a container ship. And during the production, there's 80 sensors measuring different things. And also in healthcare, of course, we have machines, we have also other devices. And here, processes can bring together all of this in an integrated way so that we can understand the interrelations between all these aspects. Nonetheless, okay, I'm a computer scientist and we do many technical things, but I have to say, most importantly, we should keep human in the loop. Yeah, so it does not work, and we cannot introduce something without supporting humans to understand what is going on and really providing something that helps. Yeah, I'm always sad if I see that, for example, this morning in the hotel, the complete system was shut down and everyone was very desperate and I could almost not check out. And then I'm very sad because this does not help people but hinder them in their work. So I would really advocate computer scientists to work on something that really helps people. And to always keep them in the loop, let them understand what is going on. And here, there's something that we really have to consider. Okay, processes are great, and I would really love to have processes everywhere, explicitly described, being used for analysis, for automation. But the big question is, how do we come up with our process models? A process model is a description of the process, and in most cases, we use some graphical notation to describe these processes. And this is still often a manual and therefore cumbersome and tedious task. So, the question is, how can we help here? And if we look at the situation, traditionally, what is happening is, let's say we are talking about a logistics process. I have an example here. It's maybe kind of simplified, but for presentation reasons. This is about a product delivery, and it's in a textual format, okay? And what happens typically is that in a company, let's say the company wants this process to be modeled, and then consultants come to the company, talk to the people, see all the textual descriptions, and then in an interplay between the domain expert, in this case this would be the logistic expert probably, and the process modeler, a graphical model is generated. And here you can see this graphical description is reflecting, hopefully, the textual information. And as notation here, we use business process modeling and notation. This is the standard, de facto standard for business process modeling nowadays. But what is the cumbersome part here is this interplay between domain expert and process modeler. Domain expert typically knows everything about the domain, for example, about this logistics example here, and the process modeler can model, but doesn't know about the domain. And here there's some gap, and this often costs. Yeah? So when we look at experience here, we can say that the acquisition of such models consumes up to 60% of the entire process management project. And the main part lies here in this interaction. Yeah? So there's going back and forth until hopefully the model then in the end reflects what is really going on. Now, question, can we help here? Yeah? And thanks to the big advances in AI and all these upcoming advances, for example, with large language models, we thought, what if we could manage to replace the process modeler by a chatbot? And here now comes the conversational process modeling part from the title. The idea is, can the domain expert, for example, the logistics expert, him or herself be enabled to create the process model without all the interactions with the process modeler, but instead of interacting with a chatbot. And the conversation here is really meant as conversation, so back and forth, domain expert and chatbot interact until the process model is created. And what could be the benefit here? Benefit here could be that, let's say, an expensive part of consultancy and process modeler does not have to happen. Therefore, also SMEs could benefit from this, for example. And including the domain expert more in the modeling is also very promising, that the models in the end really reflect the case, for example, the logistics case that we want to model. And we have started to look into this. Even, I think we were quite one of the first ones in this specific area to look into this. And if we take now the example from before, that's the same text as in the beginning, again, this logistics example, then what we have to do is, okay, we have to provide a prompt. I don't know how many, can we maybe with raise of hands, have you ever tried to interact, for example, with ChatGPT? Who has? Ah, yeah, okay. Yes. See, so very good. So already it's very clear. So we need some prompt. Yeah, the prompt is the interface to the chatbot. We have to know how to talk to the chatbot. And I mean, I've now seen there's many like certificate courses coming up with, okay, become an expert in dealing with chatbots and all these things. And they mainly deal with this prompt engineering part. That's important, of course. For us, we want to keep it simple. We want to more concentrate on the output then and to see what the quality is. But the prompt is definitely important. So what the prompt should contain is, of course, the process description, because we want to translate this into a model. And then we have to think about the output. So what do we want? We want to have a graphical, a model representation of the text. And the thing is that at the moment, the LLMs, so GPT and so on, are not able to produce a graphical BPMN model, like the notation you have seen before. Therefore, we started to use what is possible, and there is at least two options, and these are general purpose graphical notations, and one of them is mermaid.js. Therefore, we also provide some rules for the prompt that you can just put after the process description, and then the chatbot creates a graphical model like this. Okay, good. Then we have a graphical model. Our hope is that then the domain expert can maybe interact with this model. We still have to test with them how well this is working. And then we can take this graphical model, this is the same example as before, and also translate it into something which is really executable. So this is now another graphical representation. It's the cloud process execution engine. That's open source software that's built by us, and it's used in manufacturing already in 7 companies, operationally in 16 process scenarios, where there's really a running program behind this. And yeah, it's also open source. You can see it has more than 500K downloads, so it's a widely used software, so to say. And by importing the mermaid into this representation, we can show that this is a correct process model. Okay, good. This is already some achievement. And we can now, with very low effort, take this textual representation and create an almost executable process model. However, the big question, and this is the biggest question of all, is how good is the quality of what we have produced? You know, there's all these things going on. There's hallucination. The chatbot can create stuff that is not there, and all these things. So definitely, and this is the main part of what we are looking into, is to provide a framework of KPIs to enable the measurement of the output quality. This is, I think, most important. And yeah, we have test data sets. We have looked at different LLMs. Yeah, at the current work we have GPT-3, 3.54. In the newer work also Llama. There's all time something coming up. But for us, the framework can be used with all of these LLMs, and you can then test the output. And we have provided a set of KPIs that measure automatically, for example, the completeness of your model. So how well does your model reflect the text in terms of similarity, whether or not all tasks are there, and all these things. And this is already, I think, good to have a quantitative way to measure it, because then you can reason about these definitely very important challenges like hallucination and all these things. So you don't have to only look at this and say maybe it's good or not, but you can quantitatively assess the quality. So our findings at this moment are GPT-4 reaches pretty good similarity between the model and the text. And if we not only measure the completeness of our output, but also the correctness, then GPT-4 also performs significantly better than GPT-3. Yeah, of course, there's all different kinds of influence factors that have to be taken into consideration. So the prompt plays an important role. And also, of course, the complexity of the input process description. And here we have, yeah, of course, plenty to do. There's not only process descriptions, but there's also regulatory documents, which are much more complex and contain much more information that is not relevant for the process. So we have to also be able to deal with that. Yeah, and what was also interesting, so if we generate models, if they're not complete, they can also not be correct and vice versa. But I think it's maybe one of the first attempts here to provide a framework if you want to try this and to say, well, do I want to come up more quickly with a process model and I want to test out whether or not something like ChatGPT can help me, then you can use maybe this as a basic framework to assess the quality of your models. And we have closed the loop. So this is not only like creating models from text, but also we have to go back. We want to also create text from models. This is very important for documentation, for example. So processes cannot exist like only per se, but also we need a documentation, like for any software program, ideally. And so we have also worked on this to have this whole transformation loop. And this is a project that we are doing with SAP Signavio to be precise, and they see this as part of their generative AI strategy. Yeah, they provide software where they also look into process modeling, and I think here this could be a step ahead to enable more companies to have their processes explicitly modeled. Good. Okay, this is one thing. But you could ask, yeah, okay, nice, maybe I can play around with that, and maybe you have even tried to do that already. But what can I do with this now? So what can I do with these models? So what we have seen here, we have used AI to generate process models. And as I said before, and also Henrik said that, processes are key to transformation. Okay, good, but how? So in the rest of the talk, I want to shortly talk about how we can use the models now for transformation, and again, employing AI techniques for that. So process models can be used to automate processes. And here we have made very good experiences in the manufacturing domain by taking processes and using these processes to collect data in a contextualized way. What does this mean? It means that with the sensor data that I mentioned before, if we have a production process and we have this process model and we connect the task then, for example, to the machines, here we can use all the different interfaces in the manufacturing domain, UPC, UA, all these things. And then we can collect the data. We can say, okay, here we have data that is generated during the robot puts the part into the machine. Then we can collect the data that is produced in the machine. Then we can collect the data that is produced by measuring the quality of the product. And we exactly know which of the sensor streams are produced during which task of the process. They have a context. And this is entirely new thinking and brings a lot of benefits when analyzing the data. Because otherwise you have just a chunk of sensor data. Yeah, a sensor stream is a time series. Yeah, you have temperature over time, and then you have 80 of this or 10,000. But what can you do with that? Yeah, you can see, okay, well, here obviously there was a peak, and then it dropped. Yeah, okay, and then what can you do with that? But if you know that this happened during a certain task, let's say during delivering product from A to B, and you can see what happened before and what happened maybe afterwards, then you can make a lot of more statements about root cause, for example. And this is really, I think, in the manufacturing domain, I see more and more companies. So we visited 2 of them last week, and they were really excited, and will also start projects now with us with this contextualized data collection. And if you can do that, you can use process mining, you can do predictions of the quality of your product, for example, in the end. And it can also be used, and this is something I want to shortly close my talk with, which is, to my experience, also one of the biggest pains for most companies. You can use it for compliance verification and monitoring. And I don't know what you think about it, but as I said before, compliance is not like the most loved kid in the family of all the things you can do. And it's partly because it's really super complicated. So, I mean, I can say, okay, I'm a university person, but believe me, there's also a lot of compliance issues going on. We have all legal requirements when it comes to, how to design a course, do the studies, everything. But I think it's even worse in logistics, for example. And I just looked up yesterday evening in the hotel, I have to admit, what you have to comply to, for example. This is legal regulations for freight transport. This is only one thing. But you can already see you have road haulage law, you have waste law, you have all these things. On top of that, you have, of course, independent regulations like the GDPR that you have to adhere to, and so on and so forth. And the thing is that compliance is okay, you don't have a real direct revenue of being compliant, but the thing is always, if something happens, then it can become expensive. So, of course, also some kind of risk assessment that we have to do. But if we have our processes, at least we can help with compliance verification. And also here we have really looked into also logistics a lot. We have not only these legal regulations, but also we have more from the, let's say, case stemming regulations, so instance spanning regulations. For example, if you have a transport process and you do bundling, unbundling of cargo, how can you do that? How can you monitor that? And also in the manufacturing, we have a lot of these spanning processes when batching parts together. And how can we now support these kind of compliance requirements by our processes? And here, for example, this is a process model of a supply chain. Here we have different partners, the supplier, the special carrier, middleman, manufacturer, and also the bulk buyer. And in a process world, we would say, okay, each of these partners has its own process model. Let's say the supplier, for example, who is starting here. Let's see, it's the bulk buyer sending something, the order to the manufacturer, then the manufacturing process starts, does something, orders then from the intermediate, then the intermediate, the middleman starts, and so on and so forth. You can see that these process models are connected by message exchanges, and altogether then is a supply chain over several partners. I mean, if you can create this kind of thing with ChatGPT or so, let's see, this is now a steep step forward. But for the compliance consideration, if we think about it, how complex the problem is. So let's assume we have seen all these regulations before. each of these partners has this regulation, has to obey to them, has to show the compliance. And possibly these different partners are even in different countries, so different regulations hold. Yeah? It becomes quite complex. And in the worst case, you have regulations that not only hold for one of the partners, but even span across several partners. Yeah? So if you see the first, so here this could be a compliance rule, after production a final test is required. This is a rule or a compliance requirement that holds for the manufacturer and can be also checked and verified by the manufacturer based on the process. But then you could have another one. Yeah? The intermediate has to be packed before it's transported. Yeah? Then you have a compliance constraint that spans the processes of the supplier and the special carrier. So how do you check this? Yeah? If two partners are concerned. You can, of course, check this if you know the process. You can even check it via this message exchange that this compliance requirement would be fulfilled in this case. But only if you know the process. If you don't know the process, you cannot really check it. And last but not least, we have a special case here. Here we have a constraint where we don't find the parts of the constraint in the model, because they refer to private parts of these models of the partners. And we cannot check it on this basis. This is an open question still. But by knowing the process, at least we can provide the basis for the spanning compliance requirements, for example, between supplier and the special carrier. But it's complicated, yeah? And if we don't know, we can never really say if this holds or not. Good. So, I mean, this is only two parts of AI. I could have talked about process mining and all these things and the sensor data. I have many things that I want to convey, but I thought maybe, as also one of these hot topics nowadays, let's talk about the chatbot thing. And from our experience now, we would say chatbots, you can use them for creating your models, but you really have to make sure that the process model quality is good, so results have to be taken with a grain of salt. Yeah, we can say, I mean, the output is really the key here, and as we don't have the BPMN format ready yet, we are using this Mermaid.js, but it can be then also used, for example, as input for a process engine, and therefore we come closer to an executable process model. If you have process models, then you can use them for doing other exciting AI things, for example, process mining. And I would really advocate, if you are interested in collecting your data in a contextualized way, to think about a process-oriented data collection. With the process models, you come one step closer to being able to check compliance requirements. And in the end, you can also do, for example, more predictive things. Yeah, I have not touched upon this. But if you know your process, you have maybe already observed some behavior, you have your compliance requirements, you could do even predictions. You could say something like, okay, here we already run very close to a deadline. It's very probable that we cannot keep the deadline, so we have to take maybe some other action here. And I just want to say we have a nice project, and I don't want to go into details here. We have a nice project at our university. That's a foundational research project funded by the DFG. It's a graduate school. It's called ADONE, Advanced Optimization in the Networked Economy. And here we work really on logistics and transportation. And it's a joint project between School of Management, Mathematics, and Computer Science. There's a lot of going on with optimization problems and all these things. And what we try to contribute is to deal more with a data-driven approach to it. I know there's a lot of things going on. Okay, we have a certain problem and we solve it. We try to solve it exactly, all these things. We are more commonly from the real-world, data-driven kind of side and want to bring the worlds together here. There's still some gap, to be honest, but I'm hopeful that we will be able to build bridges here. But we are not doing only fundamental research projects, but we also collaborate a lot with companies, mainly manufacturing, but of course also we would love to complement this with collaborations in the logistics domain. So if you find anything interesting, for example, this data collection part, the compliance part, or also this ChatGPT-based part, then please contact us. We have different ways to cooperate, university and practice, so yeah, would be great. Other than that, thank you very much, and I'm very much looking to hopefully controversial discussions now. Thank you.
To go a little bit above of all what you explained us, we could imagine to film the scenario, and that after the artificial intelligence could devise and could automatically design the process instead of to write it before or to descript it before.
Yes, definitely. Thank you very much for this question and comment. There's definitely more that we can do. So this is our starting point, and particularly if we combine, let's say, the chatbot with other, for example, AI techniques, then we become much more powerful. We can also think about already doing, let's say, process mining, having these results coming up with the process model. We can think about having a process model and then do optimization directly on the output. So here the assumption is a bit that we have only the chatbot and only the chatbot capabilities, but this is of course a starting point, and we want to combine it with all other different kinds of things, and then it becomes much more powerful. Yes.
So I'm not sure. Oh, it's working. So maybe let me ask you a question in the meantime. So how do you see this progressing? So we saw that the difference in performance from GPT-3 to 4, I think you was like 50% better. So do we, and you mentioned in the beginning the human in the loop is important. So will we eventually get rid of the human, because we can just take all kinds of text from the organization and we can automatically generate processes. They are automated, so we have a digital transformation just out of the box. So how do you, is that something that you see coming, or are you critical, skeptical?
Yeah, this is definitely a very, very good question. And this has been a criticism for business process management for all the years. Do we want to replace the human? Also with process automation, of course. So for process automation, definitely. So I haven't shown this today here. We were able, for example, to replace the manual measurement of a part by a fully automatic solution. But here the thing is that then a skilled worker can do better things, other things, analysis questions, for example. Here with the generative AI, with this process model creation, I mean, at least we need the domain expert for sure to be able to validate the model. And I don't know if we can really replace the process model entirely, because this depends now, and this is, I think, very interesting research question, how well or how good can the domain expert work with this and come to satisfying models. We hope that there is some improvement, at least, and I think also, yeah, with our partners, SAP Signavio, I think they're also very excited. They see definitely chance in that, and we do too, but we are now going into these user studies, and then we will see how this is also going to be adopted. The adoption part is also something we don't know. But the hope would be to open the whole world of this process benefits that we could have also to, for example, SMEs, that people really can sit there and do it also themselves. An experience from manufacturing domain is, so here we have domain experts and we start to model with them. So definitely in the beginning they need support. And but as soon as they get more familiar with that, they can even not stop. So I could show you process repositories where there are 10,000, well, no, not, but a lot of models in there. So this is maybe what we want to achieve. Not really replace people, but make more people able or enable people to create process models. Because I've worked in this, I mean, I don't know, you are younger, but I've worked into this so many years, and I'm really, really disappointed. So I think this is such a great technology, can bring so many benefits, but it's not really there yet. And this is what bothers me, and therefore I will do everything to make this happen what I can. Yeah,
yeah, thank you. Got it?
It's on. Ah. Yeah. Hello, thank you for the presentation. I had a question about the complexity of the processes. So the processes you showed, maybe just for illustrative purposes, were linear with a few forks, so fairly simple processes. But when we think of more complex processes, also when it comes to transforming logistics, circular economy, where you have a lot of loops, etc., the processes get a lot more complex, and I'm wondering if you're looking into this, or how well AI is able to map these processes, etc.
Yeah, thank you very much. I totally agree. So the real world processes that we see are much more complex. So we have done like projects with automotive companies where we modeled ourselves by hand these processes, and then we had the wallpaper which was 9 meters long. Yeah, if you printed it out, so this was the process. It was super complex, also with very complex patterns. Yeah, totally true. Loops. Variable parallelity, whatever, you name it. And definitely real world processes have this complexity. We have now started with, let's say, more simple process to get some idea. And also, I have to say, the data test sets that are out there have a limited complexity. So we wanted to, for example, the PET data set, all these things like our state-of-the-art data sets. But this is for sure something that we have to really investigate. We feel that more complexity will also influence the output. And definitely then we have to also find KPIs that maybe take into consideration the complexity as well. Yeah.
I'm wondering about the optimization aspect. So typically, if you start mapping a process, you spend lots of time on it, and you start to rethink how to improve and change the process. So now you don't have to do that, because you map the process hopefully more or less automatically. Can the software or can any packages already support in optimization?
Yeah, this is also a super good question. So what we are talking about here is, let's say, the more this idealized as-is process coming out of the process description. And definitely what we would have to do, and this is also something which we are looking into, is to kind of compare it with reality. So we have our real-world behavior. And there is, for example, techniques from process mining, again, so conformance checking, where we can map the real-world behavior against these models and then see if this holds or not. And we should definitely do that and see where there are deviations, and then starting based on this to optimize the process too. And then also, of course, see with the predictions that we can make, maybe we can do even better than these as-is models. I mean, these textual things, where do they come from? Also when someone thought about how this should look like. But if this is reality and if this is the best way, this is also a very good question, yes. We have to combine this with more techniques and to really then see if we come from the as-is process to something what we really want to automate later. But it gives us already some ideas, so to say. So we can discuss based on these models, and we can also test them, for example, simulate them with what-if analysis, all these things, and then maybe come up with an optimized. Yeah, this was only really the first creation step which I presented today.
I'm charged with time management, so I hope, Dietmar, we can take the question offline. Stefanie, thank you again very much. We have a small present for you.
Thank you so much.
Yes, thank you very much for your talk, and I hope that you got inspired a little bit, and if you have more questions, obviously Stefanie will be around.